Jai Hind everybody, I am Dr. Rashmi Sharma from Department of Information Technology from Ajay Kumar Garg Engineering College. Today we would be discussing some topics of consensus which is being used in the blockchain, which is in unit 2 of the subject blockchain architecture and design. So coming to why do we require, what would be the different topics which we would be discussing here, what do we mean by distributed systems, blockchain as a distributed system, consensus over an open network, and Bitcoin, how it uses the open blockchain network. The keywords which would be discussed here is distributed system, consensus, Bitcoin, and what do we mean by open consensus, because obviously the Bitcoin uses open consensus. So coming to what do we mean by consensus, practically other nodes in the network needs to agree on the new node which is being added in the blockchain. As I'm the validator or the miner, and if I'm going to add a particular node, other nodes in the network should verify it, should validate that particular node, and that is the classical distribution consensus problem. How we can verify it, how the other nodes in the network would agree on it, how many nodes should agree, can everyone agree? In this particular class, I cannot satisfy each and every student. So how can a particular person who is adding a node would be able to satisfy each and every other node which is there in the network? So we have to take into that particular category that it should be the minimum criteria, and if I take this particular criteria as the 1/3 of the number of users, and if I have 99 users, and if I tell 1/3 or the 33%, that means 33 users, if they agree on this particular block, then I would add this particular block in the blockchain. So how can we make this decision in a distributed mode? Maybe we take a majority and then decide it, obviously like we do it in our election. That is a sort of consensus. And if no party gets the majority, then they combine up and they make a party with, then they make a government with two parties working together. So similarly, how can we get this particular decision in a distributed way and then take a major voting as a decision? So why consensus is being required? Definitely reliability. We have to rely on some person. So according to the reliability, we have to rely on some others, that the work which I am sending it is being relied by some, and they believe on me, and so I would be able to add it. Or as I told, we don't have to trust each other. If they don't rely on me, then they would verify themselves, and then only we would be able to add into that particular blockchain. Analyze the fault tolerance. What do you mean by fault? Some of the nodes in this particular network may get faulty. Maybe I have this particular network, and in this particular network, assume that this node by chance gets into some fishy thing, and this node is ready to send some information which is malicious. Maybe he has to send a value as a 10. That was the original value which they have to send, but he is not sending the 10, but he is sending the value as 12. Only changing that particular value by 2. But that would definitely change something in this particular network, because as we told in the blockchain, each and every node should have the same databases, and that is the DLT. So each and every node should have a distributed ledger that should be in sync with each other, so they wouldn't be having the syncing here. So that is one type of fault where a node acts maliciously. Maybe this particular node, this node N1 was rigorously working, and by chance that processor got crashed, and the processor got crashed, so N1 node is now not able to work because the processor is not working. So this is called as crash fault. So we can have n number of crashes. Maybe the network, this node is working, but this link is not working and not able to send the information to this one. So this link. So maybe the network can be at fault. Maybe that particular person is working maliciously. So node can be at fault, or there can be a crash of that particular node. So we have to look into n number of things which can result in fault in this particular network. And when that system is faulty, then we have to see how, because that is why we are telling there can be some nodes which are faulty, and to overcome that particular faulty things, I have to decide what should be my lower limit so that I can give the acceptance, and the Bitcoin gives that acceptance as 33%. So that 33% is 1/3 of the number of nodes which are there in that particular whole network. Okay. So ensure correct operations in the presence of faulty individuals. If this is the faulty, then if this particular node is acting maliciously, then I have to check this particular node each and every time that he doesn't creates any mischief in this particular network or doesn't does any fishy thing here. So commit the transactions in the database, only then it would be committed if this is not doing anything, or obviously we are taking 1/3 of the nodes, so we are not considering this into that particular 1/3, and we won't take his view or concern into this particular 1/3 one. Then state machine replication, from going from one state to another, we are replicating that particular machine, and how would that take place. Then the clock synchronization. Clock is synchronized at the same time as might have studied in COA, that is computer organization architecture. So we have a specific method that is called as, we have some specific methods which are called as the message passing methods. And when this is similarly like we used to send the paper mails or the inland letters and the postcards, that we should have a specific address for the person to whom I have to send the information. Similarly, you have the same in your normal emails also. If I don't know the email of that particular person, how I would able to send the information through mail? So definitely the paper mails which we used to send, there also we need an identity of the other, and works within a closed system, a specific mail. If I am sending this particular, usually down the line by 10 years, it was if I have a Gmail account, I would be able to send information only to the Gmail ones. If I send it to the Yahoo ones, then definitely it would take more amount of time because it has to go from one domain to another domain. So now it's not the case. You are not looking into that particular scenario, but to go from one bank, you might have seen those particular transaction happenings for the bank also. When you are sending the money in the same bank or in the same, if I have an account in ICICI and I am sending the money to any of the other ICICI account, maybe that account is in Pune, but I would be able to send it immediately. But if I have to send money in some another account, maybe in the HDFC bank, which is in Delhi only or which is in the Ghaziabad only, then it would take a amount, because that is beyond my vicinity, because it is beyond my that close group of ICICI, it is another bank. So I should know the account number, I should know the identity of that particular person, and then only I would be able to send the information. Okay, so all these particular messages which is being sent are usually done in two ways. One is the synchronous message passing, another is asynchronous message passing. Synchronous is we are in sync with each other, same time, same duration. So in synchronous, the message must be received within the predefined interval of time. Obviously, we have a deadline that if I am sending a message, it should reach within 5 minutes to that particular email address. If it doesn't reaches in 5 minutes, that is prescribed amount of time. In that prescribed amount of time, we have to do all those things, but not immediate. This cannot be done immediate, because you might have studied in your computer networks, we are sending the messages in the form of packets. We don't have a dedicated lines, and when we are sending into the packets, it may go out of order. We have to order those particular data, so we require a time. So we define that in a prescribed time duration. And strong guarantee on message transmission delay. So we guarantee that there won't be much of the message delay, as we have given a predefined time to them. In asynchronous mode, there is no upper bound on the message transmission delay. We don't have that these messages would be delayed within 10 minutes. Maybe they can be delayed after 8 to 10 days. Like if I send some letter, from post office, either in the form of the inland letter, that the blue one, or this postcards, that is the yellow one, they won't guarantee in how many days it would reach. But if I do a registered post, they would definitely let me know in how many days it would be reaching to that particular location. So 3 days, 4 days, 8 days. So that is the difference between your synchronized and asynchronization. You have some specific duration within that message should reach is a synchronization. When we don't have any upper bound in which the message can be sent, is your asynchronous form. So no timing constraint is there. Message can be delayed for arbitrary period of time, that is asynchronous mode. So we usually work in asynchronous mode, not in a synchronous mode. So definitely that's why we have some things. This FLP impossibility results which came into picture while it in 1985. So its name is FLP 85 impossibility result. It is purely asynchronous distributed system. Whenever we are working with this, we have to keep in mind we are working with asynchronous system. So we don't have an upper bound for that. As soon as I get 1/3 review votes, I don't see that they are sending the results afterwards also to me. So the consensus problem is impossible within the deterministic solution. So it is not a deterministic solution. So impossible with a deterministic solution. So to solve if in the presence of single crash fault. So if there is a single crash and if I tell that I have 99 nodes and one is sending the message. Okay, so 98 should send that it is a valid, send that particular message is a valid. And if I don't get a message of any two which crash faults and I get the message of 97, I won't be able to tell the consensus. So we give some particular amount that this much nodes I will get, and we would be getting that particular node as upper bound, and we would be completing that particular transaction. So results by Fisher, Lane and Peterson, most influenced paper awarded by ACM, they randomized this particular algorithm, and we got this as a distributed consensus literature review. So here the consensus is impossible to fully synchronize nodes even in your crash faults. We have two things. We cannot ensure the safety and liveliness together. What do you mean by safety? Safety is the correct process will yield the correct output. So this arrow has shifted, it is this. The safety is the correct process will yield the correct output, and liveliness is the output will be produced within the finite period of time. So we don't ensure liveliness of the data, but we ensure the safety of the data while we are considering into blockchain. Okay, so blockchain consensus deals with more of safety or 100% of safety, but less amount of your liveliness. So safety is correct process which will yield definitely the correct output, but the liveliness is the output will be produced within finite amount of time, eventually the termination. So I told we have less amount of liveliness and we try to have 100% of safety in our blockchain consensus. So in distributed in 1989, Lamport started talking about the Paxos, which is also known as the Paxos consensus algorithm. In 1990s, everyone was confused about the correctness of the Paxos, and in 1998, Paxos was published in ACM transactions, and then it got the recognition. That is after 9 years it got the recognition. And 2001 the FLP impossibility paper wins the Digestras prize, and then it was been implemented for the distributed system. In 2009 the Zookeeper released, that is another algorithm, and the services are being managed in the distributed form by this Zookeeper algorithm. So in distributed consensus 2010 onwards, different consensus algorithm were released. One is the multi-Paxos. The Paxos was the first one in 1999, and in 2009 after 10 years they got the recognition in ACM. Then RAFT, Raft, then Byzantine fault tolerance, and PBFT is practical Byzantine fault tolerance. These are some of the algorithms which we would be discussing in coming videos. So in Synchronous, various consensus algorithms were explored, that is Paxos, Raft and Byzantine. PBFT we used in asynchronous mode, which is being used in our blockchain. So what do we mean by distributed consensus? Here we have a diagram where each and every node is having some specific values on that particular link. So if there is no failure, it is very easy to get us trivial consensus, but if there is a failure, then definitely there is a loss. So we would be having this information which is being sent. See, the 10 number is sending 10 information to each and every of them. Here 40 is sending information to 40 each to each of them. Each and every node has 3 inputs. 1 from 40. See, I am taking this 30 as a which is getting input. It is getting one input as 40, one input as 10, and another input as 20, and 30 itself. So it has got input 10, 20 and 40. So maximum if I take of this particular value, then value is 40. Again here it is 10, 30 and 40. Output is maximum I am taking is 40. Here I get 20, 30 and 40. Output is 40. Here I get output of 10, 20 and 30. The output is 30. Considering the same node, if I consider that value also here 30, then it would be 40. Here 20, then also 40. Here 10, then also 40. But if I consider 40 here, then output would be 40 if I take the maximum. Each and every node will be in sync with each other with having a maximum value of 40. So that is the distributed consensus. But if any of the node gets failed, then definitely we won't be having this particular values. So there can be various types of faults. As I discussed in last day, we can have a crash fault. A node suddenly crashes, it becomes unavailable in the middle of something. Then the network or the partition call, when there is a link failure in network or the partition fault, the network gets it's not working and the node is not able to communicate. Then we have a Byzantine fault, where I told that a node is working maliciously and it tries to send a value of 12 instead of 10. So here the node is misbehaving or working fishy or maliciously. So these were the three faults which were being discussed here. So now what are the different properties? Obviously, the consensus should get terminate. Every correct individual decides some value at the end of consensus protocol. If I reach this particular value, then definitely it's over. Then validity, if all the individual proposes the same value, then all correct individuals decide on that particular value. Like here we came out to be the maximum value as, we came out to be the maximum value as 40. So that is the value. So here we should have the validity of that particular transaction. Integrity, every correct individual decides at most one value, and decide value must be proposed by some of the individuals in that particular network. Definitely not each and every is possible, as we took that in Bitcoin we can have 1/3. So 1/3 nodes, if they are proposing it, that would be the integrity of that data. Then agreement, every correct individual. Say each and every time we are using a word as an correct individual, because we know that it is not having any fault, any type of the fault, crash fault, network fault, or the last one was your Byzantine fault or the malicious node working. So any of the node which is correct fault would have this correct individual would have these particular values. Then the correctness of the distributed consensus protocol is taken by safety. The correct individual must not agree on the incorrect value. If I get somebody, if I see that somebody is doing fishy and I have a doubt on that particular value, and if I calculate the no, it should come 10 and not 12. So I should not agree on that particular 12 value. I should raise a voice and tell no, this value should be 10 and not 12. So nothing bad would happen if I have that I am raising that particular value. Liveliness is every correct value must be accepted eventually with some time. Every good happens eventually only. Okay, so by time, so we should have 100% of safety. Try to have 100% of safety. Maybe the liveliness may decrease. So why the consensus can be difficult in a certain scenario? You see, here I have, this is a message passing, and here one of the general behaves maliciously. I have 4 generals and they are passing information to each other. This general is passing information as attack. This general is also passing information as attack. This general is also passing information as attack. But when this general is passing, he is sending one information as attack and one as retreat. So this person is receiving 2 values, both are attack. This person is receiving 2 values, both are attacked. This person is receiving 1 value attack and 1 is retreat. This person is receiving both as attack. So all these 3 are in sync, but he is out of order because he has a dilemma. 50% of it is coming as an attack and 50% as a retreat. What he has to do it. So because he is not malicious, but he is in confusion state. Malicious is this one. This is a Byzantine one, Byzantine fault. This is sending a wrong information. So this general is acting as a malicious person. So we won't be able to have 100% consensus in this particular distributed one. So it is difficult to get this 100% consensus. And so because maybe not because of him, but he has received that particular information and he cannot decide. The malicious one was this one node. This general is the culprit, but this is facing the problem to take a decision. Okay. So consensus in an open system, like we work in our shared memory. In shared memory, it is not suitable for internet grid computing. Where do we put the shared memory? Where we can keep, because when there is a sharing memory, anybody can come and update that particular information. So Bitcoin is an open environment where we don't have a shared memory, but as we have seen in our last video, we have a distributed ledger. Each and every person is owning their own particular databases. So anyone can join the Bitcoin network. It's open for all. So it is an open environment. How do we ensure consensus in such an open system? And that is definitely by a key challenge. So what do we mean by key challenge? In coming to this, in the key challenge, we need a leader, obviously. I am discussing this key challenge which was here. What do we mean by key challenge? Okay. So we need a leader. And why do we need a leader? Because nobody knows each other. So we need a leader who can guide us how to do and where to proceed. Second is, let the network elect a leader. Network elects a leader. How network elects a leader? Here comes your puzzle challenge problem. In open consensus, we get a puzzle. Okay. For if I take an example of Bitcoin, in Bitcoin, the challenge which we get is we should have eight hexadecimal bits, hexadecimal values as zeros. That is the challenge. That is the puzzle which I have to solve. And if I solve that particular challenge, then that particular user or that particular node becomes a miner. Okay, and that miner becomes the leader. So how do we require a leader? How do we elect that particular leader? By throwing a puzzle challenge, and that puzzle challenge for a Bitcoin is we should require 8 hexadecimal values as zeros, then only we would be accepting that particular hash value. Okay, so when a person is able to generate 8 the hexadecimal values as zeros, then we elect that particular person as a miner, and that miner will become the leader of that particular network, because network gives a puzzle. Obviously, how that leader is being elected, because we give a network a puzzle and everyone tries to solve it. Each and every person solves it, not only this person, and one who gives the solution becomes the leader. That is the way how we elect a leader in this. And this is also called as a puzzle challenge problem in our open environment. So whatever that leader says, everyone agrees on it. The miner is sending that particular block, that this block has to be added in the network, and so that block is being added to that particular network. Then different leaders would be there at different round. Eventually, everyone is satisfied. Not always the same person would be the leader. Each and every person would get a round. If I come to your class and in each day in the morning, I tell that this person, one different person would be the monitor of the class, and I take the attendance register and tell roll number 1 would be for today, roll number 2 would be for tomorrow. So for each and every day, I am electing it by the property that the roll number sequence I am taking that. But here we are taking puzzle solving property of that particular person. Whoever solves the puzzle would become the leader, and everybody would agree on it. How do we do this agreement? This agreement is for the block which is being added. That particular person who solves becomes the miner, and miner adds a block in your blockchain, and on adding that particular block in the blockchain, everybody is validating that particular, they are agreeing on this. So each and every time a different user works as a miner. So how this particular consensus are being required in the Bitcoin? So Bitcoin is a P2P, that is called as the peer-to-peer network. Okay, so in peer-to-peer, each and every is communicating with each other, but not a direct, but a virtual connection. You might have studied in your computer networks. So Alice broadcasts a transaction, and that Alice broadcasts the transaction in a P2P network. All the nodes in the network needs to agree on the correctness of that particular transaction. Whenever that particular Alice is sending a transaction, all different nodes, Alice is sending it by signing it. That is the digital signature, and by signing that particular thing, she has to pay some amount to the Bob. So she's signing the transaction. All the nodes in the network tries to see, does Alice have that much of amount, or Alice is a valid member of our network, then she would be able to send in a, and Bob is also a valid person of our network, then they would be able to send the money. So we need to agree on the correctness of that particular transaction. Is the parties which are being involved correct? And then she has the amount which she has to transfer. Then we validate that. Every node has the block of transaction that already reached into the consensus block of the committed transactions, and the nodes also have a list of outstanding or the uncommitted transactions that need to be validated against that particular block. So a particular node here, the node, if I tell this node has two lists, one is committed transaction and another is uncommitted transaction. These are committed transaction and uncommitted transaction. These committed transactions are in the form of blocks, and these uncommitted transactions are definitely in the terms of transactions only. So we have to, each and every node has the blockchain that already has the consensus, that is the block. These are all blockchains are being added. These blocks are being added with the consensus of others. And here the outstanding that needs to be validated against the block that is being committed. So this is a particular thing. How do we add a block in the blockchain? So how consensus takes into place? So a block has previous block's hash code, then the timestamp at which that particular block was made, the nonce, that is a random number, and the TX root, that is the Markley root. In the Markley root, these are some of the transactions which are participating into it. So when these transactions are participating, we combine two transactions, we create a hash value of those particular transactions. Then we combine this particular two hash 0 and 1 and again hash it. We use a SHA-256 algorithm as we have discussed in previous videos. So that is secure hash algorithms of 256. It generates a unique 256 alphanumeric values which is there. Again, when I combine 0, 1 and 0, 3, I get a root. So we are having a bottom particular root. That root has an entry in your block. Say this is block 22, this is 23. So 23 is using a previous hash or the header of the previous block 22. So here we have all these transactions, and these are all committed transaction which I have, and these needs to be committed. These are uncommitted transactions which needs to be there in this particular list. So we have the list of committed transactions as in the form of Markle root, and these are the set of transactions which we need to be committed, which are in your uncommitted list. So how do we do consensus? Definitely consensus, if we do per transaction consensus, and if I have thousands of transactions, or I should say when I consider a Bitcoin as an open network, I have approximately lakhs of transactions per day, and in that particular lakhs of transaction, lakhs of blocks has to be generated. So we don't do per transaction consensus, that is an insufficient way. So we do a block based consensus, or in a particular block we can have any amount of transaction, we can have any number of transaction. They don't have to be in the same sequence, they can be out of order also. Here I have written all those in sequence. Maybe this particular block has 12, 13, 18, 19, 24 which are being committed and added to the block. So the transaction are definitely out of order, they are not always in the sequence only. So apply consensus over the entire block transaction, and here where we comes a block. We want to combine those particular transaction, we have to concise those particular transaction into a single block, a packet banaya, and we have to then give it. When I have to, when we purchase more of the things from the grocery shop, if I purchase one thing, he can give me like this only, take, I don't have a poly bag. But if I purchase ample amount of things, I think 12 to 15 things, he would definitely give me not a poly bag, maybe a cotton bag, and tell you keep all these things into this packet and you take it. So here the same, the block or the packet which is being given, so these particular blocks, these transactions are being packeted together to form a block. When these transactions are being validated, then only they would be committed and forming a block. So how this consensus in the Bitcoin? So Bitcoin consensus, which block do we need to add next? See, I have these transactions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. So the transaction, I told you, it can be out of the order. So here this particular person P1 has 15, 16, 18, 19, again out of order. This P2 has 15, 16, 17, and this P3 has 15, 16, 17, 18. So which block can be added? Definitely the person who creates, who solves this puzzle challenge, that is 8 zeros, 8 hexadecimal zeros first, would be able to become the winner of this particular, and that block would be added to it. So here the possible solution is broadcast the information and then apply a choice. Traditional distributed consensus, everyone should agree, this is consensus of our Bitcoin. Or either observation 1, any valid block, a block with all the valid transactions can be accepted even if it is proposed by only one miner. If only one proposes, maybe out of order, maybe in sync. Here they have 4 transaction, he only has a 3, and if he proposes, only 3 transactions can be added to it. Then the observation 2 can be, the protocol can work in rounds. Okay, and the broadcast accepted block to all those peers, collect the next set of transactions, and then we can propagate these particular transactions. And every miner independently tries to solve that particular challenge of the keyword, and when that particular challenge is being solved, the block is accepted by the miner who proves first that the challenge has been solved, and the challenge was 8 zeros for the 0 hexadecimal values, and thus that has a solution. Since that I have the solution, see, he has 15, 16, 18 and 19 out of order. No, not in sync, that 17 is missing there. If that is, he tells everyone that I have a solution. They start validating this particular block which they have made, because the challenge which is B was given, they were also solving that particular challenge, they were also participating. Now he has that particular solution, now they would be validating that he has generated the right solution or not. After validating, not everyone can see T18. See, T18 have been committed, but T17 has not been committed, and it would be included into uncommitted list in the next transaction. So see, this is being included in uncommitted transaction in the next list, which is there T17. Now again they are finding out the mining of this particular. So here we use a proof of work which was given in DECOR in 1992, that tells that we are proving ourselves that we have done something, and for proving is, I am showing it by proving it by 8 zeros which I have in hexadecimal values. That is the work which I am showing it. So the consensus which is being used by Bitcoin is called as a proof of work. So coming to the end of this video, what do we conclude? That we have seen whatever the different classical consensus which cannot be applied on the blockchain for the distributed consensus, and open network cannot support the message passing. So definitely we would be requiring an asynchronous one. So use a puzzle solving to reach open consensus which is being used in the Bitcoin. The puzzle solving is the puzzle channel which I have discussed. We require, currently we have this particular condition for the Bitcoin that 8 hexadecimal value should be there to solve that particular channel, and hash code which is being generated has that 8 hexadecimal values. That person becomes the miner or the winner of that particular puzzle, and then it distributes that particular block that he has found the solution, and others validate that particular solution. And then why would someone solve that particular puzzle? Definitely they get some handsome amount from those for solving that, because they have to purchase the ample amount of computational power. So they get some amount for getting that being that particular leader, and then the puzzle problem is so hard that it requires a more of computing power. So definitely blockchain has a drawback that it requires a more computing power, and when we require a more computing power, we require more electricity, we require more ACs to have to keep that particular area cool, and even the ACs liberate energy. So in short, all these needs more computing power, means we are going to global warming, and in global warming it is creating a problem for our environment. So coming to the end of this video, the references were usually first was obviously a technical introduction to 25, and all these particular cryptographic things were taken from the William Sterling one. Thank you for this video. In the coming videos, we would be discussing about the Hyperledger transaction flows.